So hi everyone, I think we'll make a start. Welcome to NIHA's monthly seminar. I really like the title of today's grouping of talks. It's called Is It Time to Sea Kelp? Actually, we have three speakers today, and it kind of really shows the ethos of NIHA in that we're going right through from kind of the health effects of a particular food product to concerns about sustainability and how that food products contributes towards sustainable solutions to health, and then right through to our final speaker who's talking about product innovation. So what we'll do is we'll have the three talks, and then we'll have questions at the end. And for those of you who want to ask questions, we do it in two ways: either unmute yourself and just ask the question directly, or type your question in the chat box. And we'll ask you for the talks just to save bandwidth, just to keep your microphones and videos off during the talks and then turn them on afterwards. So back to the speakers. So it gives me great pleasure in introducing the first speaker, who I know well, Peter Curtis, an Associate Professor in Nutrition and Biomedicine in Med. Peter's area of expertise is flavonoids, phytochemicals and cardiometabolic health. And his methodology of interest is he's very much a randomized controlled trial expert. He has a recent interest in macroalgae and seaweed because of the structural similarities between its bioactive, which is the florotannins, and some of the fermentable and inaccessible tannins from plants. And also what Peter didn't say in his bio, but I thought I'd mention, Peter is a very dedicated educator as well and puts a lot of time and effort to making sure our students have a great learning experience. So without further ado, I'll hand you over to our first speaker of the day, Peter Curtis.
Okay, thank you, Anne-Marie. That was a very kind introduction. I'm not sure I can live up to that as an educator. I will do my best. I'm going to try and share the screen first. So I'm actually going to do the talk for all three of us. So Gill and then Rikke will follow me directly afterwards, if that's okay, because we thought it might be slightly difficult to sort of switch between the three of us. Okay, so if you can just confirm to me that you're seeing my full screen. Can you see the full screen there, Anne-Marie?
We can indeed, Peter, thank you.
Wonderful. Okay, well, firstly, thanks very much for inviting us to speak today. As Anne-Marie said, there's three of us. We're going to talk about macroalgae. So macroalgae is otherwise known as seaweed, and Gill is an expert and will be explaining that fully for us. We're going to talk about seaweed in terms of it being a future food source for health purposes, but also for climate crises. So when we think about healthy aging, we often think about the individual, maybe less so about the environment within which that individual develops in or grows within. And these are just some of the documents that are global documents that are out there, which have some sort of intrinsic relevance between the individual and the planet. So when we talk about the WHO document, the graphic in its simplistic form is really nice. It kind of explains to us that what we see on the functional level, the sort of manifestation of people's abilities and how well they're healthily aging, is intrinsically linked with their capacity, their physiological capacities. But it's really nice that this is recognized, that the environment within which they grow and develop is really supporting that intrinsic capacity, which then manifests as their physical functionality. In this document, it's very much about the societal kind of support. But I think it's also clear that when we look at other documents like the National Food Strategy, that there is this implicit link between the individual and the foods that they can select and the products that are available to them, and how that impacts upon their ability to age healthily. So in the National Food Strategy, it's recognised that the food system has this effect on people. Now, going a step even further, if we look at the document that was released in 2015, the United Nations Sustainability and Development Goals, 17 of them, that really recognize this implicit link between humans and how we're evolving as a community, but also how we need to be looking at the healthfulness of the planet. So the sort of one world, one planetary health kind of goals are really important for sustainability. So today we're going to talk about macroalgae, and really what is it that we foresee are the health and environmental crises that are relatable to macroalgae. Well, as I'm sure most of you will be aware, the government are very keen for us to be enjoying more health and having an extra 5 years of healthy independent years by 2035. And why is this an issue? Well, we know that over the last 10 to 15 years that the number of disability-free life expectancy years is diminishing quite rapidly, and that's quite a concern. There's obviously quite a lot of reasons for this, one of which might well be a change in the type of people that we are. As a population, we're getting larger, and that has its own health consequences. And possibly one of the more concerning issues about this sort of shift in body size as an indicator of health is that actually the right-hand side of this distribution is actually getting wider. So it's really indicating that people are becoming more obese and more severely obese, and with those conditions becomes a lot more severe health concerns. We also know from our MP in the jungle here that that childhood obesity should be reduced and halved, in fact, by 2030. And again, if we look at the most latest figures, this is not looking so good. A substantial number of our children are either overweight or obese. And as we can see in boys from the age of 8 onwards and girls from the age of 11 onwards, the levels are really quite substantial. So what we're seeing here is a potential indication of what might be happening in 10 years' time as future adults, that this tidal wave of obesity is not going to go away. Obviously, there's been an explosion of other conditions which are related to poor health, and one of which here is just an example is type 2 diabetes. And really, I just wanted to focus to demonstrate that really it isn't just about having a condition, it's about the fact that it actually inhibits your lifestyle and the way that you live. And this figure from the Global Burden of Diseases excellent resource shows us that in Western Europe, the number of years that are attributable to type 2 diabetes, being disability lived years, is really rapidly rising. And the UK is one of the worst nations for this. When we think about the National Food Plan, well, you don't need to have really read this document to be aware that there's a problem with the UK food system. You only needed to go to Aldi last week to try and buy some peppers or tomatoes. We couldn't find it. So there's a problem here. When the National Food Strategy identified how and what we need to change, it was clear that we've got an over-reliance upon meat, and we're going to talk about meat later. But also there's a real lack of plant-based foods that are consumed in the UK diet. Now, when we look at consumers, it's perhaps reassuring that they're aware that they need to eat more fruit and vegetables, and they have an intention to do so. 2/3 of people in 2021 said that they were considering doing this. What's slightly more alarming is that there is a real uncertainty about how our diet and our food intake actually impacts upon the sustainability of the planet, and there's a real resistance to eating meat, or eating less meat, should I say. So really, when we talk later about can we make the meat that we do eat healthily or more healthful for the planet, then maybe that's a sort of a strategy that might align some of these problems. Now, this isn't my area of expertise, but in terms of the climate elements, it's clear we're a growing population. The planet's becoming more crowded. The agricultural resources that we've got at our disposal are becoming more squeezed, and there's a deterioration in our soil, which really puts under pressure our ability to produce food, nutritious food. What we do know is that there's a substantial issue with greenhouse gas, and as much as we need greenhouse gas to keep the planet warm, it's also clear that that balance has somehow become set off its axes. And if we look at carbon dioxide and methane and nitrous oxide as real key contributing gases, you can see that from the mid-70s, the levels have really exploded, and there's really no sign that they're slowing down anytime soon. And I'm sure Gill will pick up on this. So today is a sort of tonic for all of this gloom and doom that I've just kind of showed you there. We're going to hopefully give you an insight as to why we think that the macroalgae could have a role in terms of making it a healthier planet with healthier people, that we can make healthier foods somehow either directly or indirectly through the consumption of seaweed, and also that we can consume and utilize products that are of a seaweed orientation, which could well be beneficial for the planet as well. So I'm just going to hand over to my colleague Gill Malin.
Good afternoon, everybody. It's a real pleasure.
Jill, do you mind if I introduce you first?
Oh, no,
and I'll just
please go ahead.
I'll tell people a few bits about you.
Yeah, sure.
So great pleasure to introduce Jill Malin, who's a reader in biological oceanography in the School of Environmental Sciences at UEA. And Jill's research centres on the essential role that phytosynthetic organisms play in the vital global biogeochemical cycles, and also how marine plankton adapt to and influence their environment and how they could alter with climate change. Gill also works on the sustainable production and exploitation of seaweed and microalgae for foods, feeds, and other products, which I'm sure she'll tell us more about right now. So thank you, Jill, for coming along to speak to us.
No problem at all. My pleasure. It's really nice to be talking to a different audience and spreading the word about seaweed or macroalgae. So I'm going to try and cover some basics about seaweed. So I hope there aren't too many of you out there who are experts. Then why do they matter in our current Earth system? And then we'll go on to say a bit about whether it could do some more for us than it does now. Next slide. Okay, so I know there's likely to be some people on this seminar who are experts in plants, much more than I am. So I'm talking about land-based plants. I don't know whether anybody works on daisies or woodlands, as we see there in the picture at the top left. But they are very different organisms to seaweed or macroalgae, which you see in the third picture with my name under it. What they do have in common is that they're all photosynthetic, and they're taking up carbon dioxide using light energy, producing a sugar and oxygen. That oxygen release is really important because we need to breathe oxygen. The CO2 uptake is also important in general, but also in the context of climate change. And the sugar is used for general metabolism, for increasing in biomass and reproduction, etc. So aquatic systems actually provide us with incredibly important ecosystem services. So we need that water. I've mentioned oxygen production and CO2 uptake. There's potential there for sequestration as well. We need the aquatic system to provide us with food, transportation, for economic reasons, for jobs, and also for cultural services. We often, when we go out for a walk at the weekend, go to a nice area with a lake or go to the seaside, that sort of thing. Also, the seas and the oceans are a really critical part of the Earth total system. It does contain almost 97% of all the water on Earth, and it really influences our weather patterns and the climate. It's an extremely biodiverse part of the Earth system, and something like 50% of global photosynthesis, maybe a little less, maybe sort of 45%, is going on in the oceans. They really do moderate man-made climate change, in particular by taking up CO2. So on the bottom left here, I've got a couple of examples of the sorts of seaweeds that could be and are being cultivated in the UK. At the top, we have sugar kelp, Saccharina latissima. At the bottom, ribbon kelp, or Alaria esculenta. They're a bit different to plants. They have a blade or a frond. Then in these cases, a thin stipe and a holdfast, which literally does that. It allows them to fix onto a surface. Both of these species grow to about 2 meters in length in general. Next slide. So macroalgae and seaweeds, they are a hugely variable group. There are 3 separate evolutionary lineages here. But at the simplest level, we divide them as colour groups according to the pigmentation. I've given 3 examples here that are edible seaweed. Many of them are edible or have components that have a potential for us to use them. So there's the red seaweeds. Here we have porphyra, which you'll be familiar from sushi wrappings. green seaweed Ulva lactuca, which you can use nicely in a salad, and the brown seaweeds like the ones I've just shown you here. So this is sugar kelp again. So they evolved a very long time ago. The red algae, something like 1.4 to 1.2 billion years ago. The green algae about 800 million years ago, and the browns at 400 million years ago. Land plants, incidentally, came through at about 450 million years. So these have been around for a very long time, evolving to the particular environments that they live in. They're hugely variable. Within and between these groups, you see differences in shapes, sizes, ultrastructure, chemical constituents, you name it, there's huge variability. Next slide. So this is a shore I know quite well. It's one where we teach an ecology field course, and this is in Kerry in the west of Ireland, looking straight out into the Atlantic. It's a shore that's not visited by people very often because the access is quite difficult. And you can see the whole spread there on the shore, the four students in the distance doing some sampling. The population in this area and in many others like it around the whole Atlantic and North Sea Channel area is rather similar population in terms of flora and fauna. The one thing that's really lacking in this sort of environment is space. So things are really fighting for space and adapting the best they can to those spaces. And you can't see here, but the this ecosystem stretches offshore probably 50 to 100 meters. If you were looking at the photograph in detail, you would see a few bits of seaweed floating on the water amongst the waves. The picture on the right shows the consequence of this sort of space. So you do have space issues. So you do have other organisms that live with seaweed, amongst seaweed, and actually on it. So using this as an anchoring point, and the associated microbial flora and fauna that they also support. Next slide. So the shore is considered a very difficult environment. The tide goes in and out twice a day in most areas of the world. But like I said, you know, they were here before plants and the dinosaurs appeared. So they've had a long time to adjust to this. So the top end of the shore here, this is a concept called zonation on the shore. And you get increasing exposure the further up towards the land you go. So the things that grow in that area have to be really well adapted to desiccation. As you go down the shore to areas in the upper intertidal and the lower intertidal, you start to get speciation where the organisms can withstand some aspects of desiccation. And alongside them, in the rest of the food web, the animals that eat and are supported by having seaweed detrital food chain. Next slide. So we have these seaweed related ecosystem services. We talked about CO2 and oxygen, but alongside the CO2, they're taking up lots of other nutrients. They are very nutritious. They're eaten by a big range of organisms. And they also set up what we call a detrital food web. When pieces of the seaweeds break off and start to break down, there's a whole food web. They also slough off the surface sometimes, or things actually feed directly on the surface of the seaweeds. So this detritus is feeding other organisms in that food web. And they provide nice shelter for other organisms, crabs, fish, lobster, all those other sort of little tiny shrimp type organisms. It's long been used as a fertilizer and soil conditioner, which tells us something of its nutritional value. And the rocky shores and the subtidal areas attached to them are incredibly biodiverse, but these days we're seeing losses of natural populations due, for instance, to marine heat waves and man's activities in the coastline. They do have potential for heavy metal decontamination, and climate mitigation in terms of CO uptake, and also some effects on methane, which I'll talk about later. So seaweed aquaculture is going on all over the world, and it's really beginning to take off in the UK now. It could have a nice social impact in terms of improving our diet, providing medicines, jobs, that sort of thing. And just for reference here, we're seeing the bottom left picture there is a seaweed that has the ability to dry out over 8 to 10 hours, goes almost to a crisp, and then it will re-wet and revive and start photosynthesizing very soon afterwards. So incredibly resilient. You also see their crabs, some Patella vulgaris, which is a limpet, and some marine snails, which eat a lot of seaweed. Next slide. So just to give you an idea about how seaweed can be cultivated, I've had a visiting chair position at the University of Malaya, Kuala Lumpur, and we've there been interested in production of trace gases of atmospheric and climatic significance from seaweed cultivation. I think the seaweed at the top is a Capophycus, or possibly a Eutuma. Different species live in different parts of the world, just like they do with higher plants. And you see there two of my PhD students in relatively shallow water that you can stand up in doing various measurements. The most typical way to grow seaweed in Northern Europe is shown, and the Americas also, is shown in the picture at the top right. And generally speaking, people attach them to ropes, which are hung out on a buoy and line system in the sea. So you really just see the buoys above the water. You put this in an area below the subtidal. Then in Africa and some other tropical places, there's a lot of production of seaweeds in very shallow waters. And there's a gender sort of bias, perhaps, in places like Zanzibar, where this picture comes from, where many of the seaweed companies are owned and operated by women. You can also grow seaweeds in artificial systems. At the bottom left there, you see some outdoor tanks and indoor tanks that are being used for cultivation. Next slide. I've also had a visiting chair at the Ocean University China, and which is in Qingdao, and I was lucky enough to be taken out to one of these big industrial scale seaweed farms in the Shandong province. This really had to be seen to be believed. It was really huge. You could see seaweed line buoys as far as the horizon. 800 people worked there, and they were just beginning the harvest. And what they do is they use small boats. You can see the guys getting the seaweed off the tractors there. They're very briefly dried for less than 24 hours. And then they go through a boiling seawater line. And then it comes out green because you lose some of the pigmentation. And it's chopped up to look a bit like spaghetti. And then within 24 hours, it's packaged up and it's sent out to the supermarkets to be used as a salad product. It was also producing feed for animals and various other products. 800 people working there, great for the economy. It helps with eutrophication in that area, which is the excess nutrients the Malin's activities put into these coastal areas. We have to avoid the issues of agriculture at sea. So, you know, when you get monocultures, there's problems with pests and pathogens and invasive species. And so, yeah, anything that is set up from new, like we're trying to do in the UK, has to be done with great care. Next slide. Just to give you a bit more idea of the large scale of this, the whole of that province, the coastline is pretty much all seaweed farms. So you can see one here from the air. Most of them are producing other products besides seaweed. And one of the really nice and sort of more sustainable ways you can grow seaweed is to couple it with production of fish and shellfish, and their waste then becomes food for other species. So in terms of invertebrates in China, they're very fond of sea cucumbers, so they often grow those, and there will be ropes with mussel cultivation systems on them amongst the algae, or further, a bit further inshore. Next slide. So this is from, I don't know whether anybody reads The Guardian, but this was from The Guardian this Wednesday, I beg your pardon. Might have been the paper the day before. It was in the Species Watch section, which is under the weather page, the little section there, and it was entitled How Sugar Kelp May Help to Tackle the Climate Crisis. So there are a lot of myths around algae in terms of growth rates and sizes, and also this carbon sequestration potential. There are a lot of big companies where they have no experts on seaweed really trying to test the carbon credits idea for profit. And they make some claims that are not really true. And this is being perpetuated throughout the press. So the production of seaweed primary production is very high. It is equivalent to a rainforest, but you have to consider what you're going to do with that carbon, unless you're going to bury it for geological time, which is how the open ocean carbon pump generally works. Then you're not going to sequester it over a long enough time for it to make a great deal of difference to our climate. So Amazon has given 1.5 million euros grant to a Netherlands company. They're setting up a farm scale trial in the North Sea, and that's what led to this article. And they're going to be growing that seaweed between the turbines, wind turbines, off the Netherlands coast, which is seawater now that won't be able to be used for much else, which is a good thing to use it for something else. Sugar kelp, I'll just read this out. Sugar kelp grows particularly quickly in early spring and reaches 5 meters long in about 4 years. The species that they're going to grow does not reach that size. It's more like 2 to 3 meters. If you left it in the water for 4 years, it would probably have been eaten by things long before you could do anything with harvesting it and set about carbon sequestration. It absolutely takes up carbon dioxide, but sequestering it is a really different matter. Next slide, please, Peter. And I think this is my last slide here. Peter asked me to make a link between the slide he showed with the increasing rates of production of greenhouse gases and their build-up in our atmosphere, and what Rikke will be covering later. So greenhouse gases are not equal. You see in the graph on the right and also in the pie chart, these figures are showing carbon dioxide, methane, nitrous oxide, and the various fluorinated gases. So if we look at the data from the pie chart is from 2014, and I've written some more recent data above. So in 2021, something like 508 parts per million of CO2 equivalents were in our atmosphere. So we use CO2 equivalents, so because the gases behave differently in terms of what happens to them in the atmosphere in particular. So about 415 or some 80% of that is from CO2. The rest is from the other gases. And that should say IPCC, but that is the International Panel on Climate Change, very authoritative report that comes out every few years that says that a CO2 concentration of about 550 parts per million would give us an average 3 degrees centigrade increase in temperature. I have to stress that's average. The temperature increase in some places would be lower, in some places it would be considerably higher. So the graph on the left shows us global warming potential. And we reference to CO2, which is given as at a value of 1, and it's a measure of the heat that is trapped in the atmosphere over a 100-year period. They all vary, these gases, in terms of their atmospheric lifetimes, and CO2 is in the thousands of years, methane is about 10 to 12 years, and nitrous oxide about 100 years or so. Some of the fluorinated gases, these are things like chlorofluorocarbons that are used as refrigerants, have exceedingly long lifetimes in the atmosphere. We had a really nice seminar in Env last week from a guy from Manchester University who's an expert on methane emissions. Now, he was telling us about some really interesting isotope work that's showing that whilst there are both man-made and natural sources of methane that ends up in the atmosphere, actually the biogenic sources are coming to the fore at the moment, and their level is increasing relative to the man-made sources. Methane is a quick win in terms of climate change in some respects, because if you were to prevent some of it getting into the atmosphere, or lots of it getting into the atmosphere, you would see the changes in the overall potency of the greenhouse gases very quickly because of that lifetime that's only about 25 years. Okay, I think that's where I stop and we hand over to Rikke. So thank you very much.
Thank you very much indeed, Gill. Now it's my great pleasure to introduce the final speaker of today, who's Rikke Nagell-Kleven. Rikke is an innovation consultant at Hethel Innovation. Her background is quite diverse, actually. It's in molecular medicine and business management, so very nice combination. And she's passionate about growing and communicating high quality science, particularly anything related to ocean and business. And she also coordinates the Algae Innovation Platform, which supports the seaweed industry across the east of England. So thank you, Rikke, for coming along to speak to us.
Thank you so much for that. Can you hear me okay?
We can indeed.
Perfect. So I'm going to talk about worldwide seaweed demand and uses, and I'm going to particularly focus on foods. Next slide, please. Just to go back to the history of seaweed and the uses in the UK. In the UK, seaweed has been used for centuries as a food, feed and soil enricher already. And seaweed has been used as a soil improver, particularly in coastal areas, because it contains several useful plant nutrients, including nitrogen, potassium, phosphate and magnesium, that increases soil fertility and also plant growth. So as we can see on this timeline, it has been used for centuries already to create soda ash for glass, in soap production, in linen bleaching, and also for iodine extraction, because seaweed is really rich in iodine. I know that Peter will come back and talk a little bit about that later. And it's also in recent centuries been used as a gelling agent in food and for a lot of different applications as well. And because of that, there has been a resurgence in the last couple of decades because of the wide applications of seaweed. Next slide, please. So just to talk about the current UK uses and farming needs. So again, there's multiple uses and products that you can make from seaweed. There's wide applications in nutritional supplements, fertilizers, animal feed, biofuels, textiles, cosmetics, wastewater treatment, bioplastics. The list really goes on. And it's also really interested when it comes to bioremediation because of its absorbing capabilities that Gill just talked about, and its ability to removing environmental pollutants from water. It's also really, seaweed is also really interesting when it comes to coastal protection, so preventing coastal erosion, because it can act as a barrier to destructive storms by lessening the impact of waves. And it also offers alternative livelihood, jobs opportunities, and new value chains for local communities. But there is really important to mention that there is a difference between the wild harvest that we saw a lot in previous times and the need for more commercial aquaculture now that we see more increased demand for seaweed. So the growing demand for seaweed for multiple applications cannot currently be sustained by wild harvest, and the pressure to accelerate local production is really increasing because most of the seaweed that we use in the UK to create products is imported from Asia. Next slide, please, Peter. Thank you. So just to go through some data from the global seaweed industry, currently it's a $16.7 billion US industry. There's around 35 million tons produced each year. As Gill mentioned, there's around 12,000 different species of seaweed. Around 291 of them can be commercially farmed. And out of the whole global production of seaweed, 95% is produced by farming activities. Next slide, please. And if we look at the UK seaweed industry, there's around 600 species of seaweed along the UK shore, mostly brown types of seaweed. That's the most abundant type. There's around at least 90 businesses in the UK that are either harvest or farm seaweed or process seaweed or offer seaweed-related services. In the UK, 96% of the seaweed is produced by wild harvest as we currently speak, and that's a big contrast compared to the 95% on a global scale that's produced by farming. Around 33% of businesses in the UK that focuses on seaweed have food and drink as the main target. 13% of businesses have nutraceuticals and nutritional supplements as the target, and there's around 15 commercial seaweed farms in the UK as we speak, and companies that have the license to farm seaweed. Next slide, please. And if we take a look at local seaweed production, as you can see from the map of the UK, there's little to none activities in the east. And there's currently 2 companies that want to farm seaweed off the Norfolk and Suffolk coast. And we're hoping that Norfolk Seaweed will hopefully have the first single line areas out in Norfolk waters this autumn for harvest next spring. But it's very difficult to say what the first yields will look like. And there's no actual seaweed production in the region as we speak right now. Next slide, please. So if you look at it from a food and drink sector perspective, it's known that by 2050, human demand for food will increase by 70%, and agriculture's capacity to sustain this demand is constrained by a lack of additional land and fresh water, and is also threatened by the climate change, as been mentioned. However, seaweed can be farmed at sea, and it does not require fresh water and land, and is therefore seen as an important future feedstock with a growing world population. But seaweed is still seen as an underutilized food source, especially in the UK, but it has this great potential. So even though there was a short-lived seaweed hype in the 1980s, seaweeds are still seen as a relatively new superfood, and it's really high in dietary fibers, vitamins, minerals, and also low in dietary fat content. And so this have also shown significant health benefits to eating seaweed, including reduced blood pressure and improved digestive health. And I know Peter's going to talk more about the aspects in a bit. So presently there is an increasing interest for seaweed. Increasing interest for seaweed, and the European seaweed market is growing every year. And in 2020, Europeans actually ate over 700 million pounds worth of seaweed, so that's quite a lot. And sales of seaweed for different uses and consumption is also projected to increase to between 1.7 billion and 2.5 billion by 2030. So globally, seaweed production alone is more than a $6 billion industry, and 85% of that comprises food products for human consumption. So, however, as discussed in the UK, farming of seaweed is currently limited, and it mainly relies on seaweed harvested from the wild, although there is an increasing number of commercial farms that have gained license to farm seaweed off the UK coast. But as discussed, as the market continues to increase, we do have to farm more seaweed locally to meet the demands. So that we don't have to import even more seaweed from Asia in the future than what we already do now. Next slide, please, Peter. Thank you. So if you look at some trends and barriers to entry when it comes to seaweed food and drink, one of the biggest tendencies that is affecting seaweed food trends is the global transition to more sustainable diets. As we all know, in 2019, the UK government committed to reduce the country's net greenhouse gas emissions by 100% by 2050. And as a part of its recommendations for achieving a reduction in the emissions, the UK Climate Change Committee has suggested a 35% reduction in high carbon meat and dairy products by 2050. So that this means that we need to consume more plant-based products. And edible seaweeds are seen as a nutritious and sustainable alternative to animal-based food products. But a barrier to consuming more seaweed and plant-based products in the UK is that meat has been a really long-standing feature of the traditional British meals. But as Peter said a little bit earlier, the public attitude surveys do indicate that the willingness to eat more plant-based diet, plant-based food is growing in the UK. And as mentioned on the last slide, the European market for seaweed food products is still dominated by important products from Asia and Asian farmed seaweeds, and products made from more locally produced seaweed may mean that consumers might have to pay a little bit more for products, for UK-based products, as UK seaweed farmers won't be able to compete with the low cost of Asian farmed seaweeds. This is particularly because of the production costs are a lot cheaper in Asia, and they also benefit from a warmer climate. And there's also a couple of other associated barriers with seaweed food products, such as food quality, food safety and optimization, and also food phobia, which is not an unknown phenomenon. And we currently see a lot of the same barriers to consuming seaweed that we see to consume more insects. But hopefully local production might be able to tackle some of these challenges and help consumers realize the benefits, both health and environmental benefits of eating more seaweeds. Another one to mention is also that cooking with seaweed might present another challenge because it might require new cooking skills, especially with using raw seaweed, and it's also difficult. It's also been difficult to get health claims approved for seaweed food products, and also in some countries, seaweed is not even seen as a food product or classified as seafood, and that presents a barrier when it comes to import and export of seaweed food products. Next slide, please. So as discussed, there are some great benefits with seaweed food and drink products, and when it comes to the UK food and drink companies are using seaweed in their product lines, and there's a growing range of seaweed and seaweed-based food products being available on the market, and this includes sushi, seaweed sheets, bread, pasta, soup, snacks, beer, and also gin. And this has been made available to consumers in both large supermarkets and also in specific retailers, with many of these products being UK sourced, like all the examples you can see on this slide. And many plant-based alternative foods on the market are currently designed to mimic and the taste and also the texture of their animal-based counterparts, where seaweed food products often have been presented to consumers in more natural forms, which potentially has increased the barrier to consuming more seaweed. And because of this, a number of UK companies are using seaweed as an additional ingredient in other well-known food products to gain consumer acceptance to eat more seaweed. And as an example, you can see, for example, the Shore, a company who makes nutritional snacks and food from self-grown, harvested and processed Scottish seaweed. And you can also see the seaweed burger patties from Bristol-based Cheeky Monkey on the slides. And another example I want to mention is the London-based company Notpla, which is a sustainable packaging company that creates advanced packaging solutions made from seaweed and also other natural materials as an alternative to single-use plastics. And on this slide, you can see their biodegradable and edible sachets, which you can have sauce in. So to sum this slide up, there are new seaweed products constantly appearing on the UK market, and it's expecting to be even more products appearing as the interest is expecting to grow because of the global transition to more sustainable and environmentally friendly diets. Next slide, please. But it's not only food and drink products that can be made from seaweed. There's also other exciting innovative products made from seaweed. As you can see on this slide, we have seaweed, vegan seaweed leather. You can make purses from it, other things as well. You have the seaweed line from Body Shop, which is used with sourcing only seaweed from the UK. And you also have joggers from Tommy Hilfiger using seaweed fabric, also from UK sourced seaweeds. That's some exciting products there. Next slide, please. So as discussed, the food system in the UK is a significant contributor to greenhouse gases. And to mention some other applications of seaweed and its potential role to help us on the road to net zero, I wanted to come back to this slide to confirm the amount of methane in the UK food system and its impact on greenhouse gases. So methane now accounts for approximately 13% of the UK's net greenhouse gas emissions, and out of this, it's estimated that agriculture is responsible for 47% of the UK's total methane emissions, where seaweed could have an impact in lowering the emissions as well as in packaging and transport. Next slide, please. So seaweed can help decreasing methane and nitrous oxide emissions associated with agriculture by being implemented in animal feed and fertilizers. And we know that a big contributor to methane emission associated with agriculture is cattle. And there are approximately 1 billion cattle at the globe at every given time. And 1 year of cow burps actually has the same greenhouse gas effects as driving from Norwich to southern Argentina. So we want to do something about this. So next slide, please. So because of the desire to lower these emissions, seaweed has been used in cattle trials. And the seaweed that's been used in these trials is Asparagopsis, which is a species of red macroalgae mostly found in tropical to warm temperature waters. Is shown to be the most effective species of seaweed when it comes to reducing methane production by inhibiting microbial methanogenesis when used as a feed supplement in cattle. And in the past 3 years, half of the $365 million that has been invested in the seaweed industry has gone into just 2 sectors, and one of them is livestock methane reduction with Asparagopsis, and the other one is biorefinery approaches. Next slide, please. So just to finish off, I just want to mention this study. So in this study, they fed cows 3 different types of food over 21 weeks. It was tested whether adding small amounts of seaweed could reduce methane levels, so Asparagopsis. And the study compared giving only 43 grams per day of seaweed and 86 grams per day of seaweed to cows that were consuming 17 kilos of feed a day to cows that did not consume any seaweed at all. And compared to the cows that produced their normal amounts of methane burps, the cows fed seaweed decreased their methane in their burps, with less methane produced with increased levels of seaweed in their portions. So the farmer found that the cattle also required less food to develop the same bulk compared to the normal diet. And the meat quality was judged to be indistinguishable from cows that wasn't fed any seaweed at all. And you can also see on there was a picture there on that slide as well that just showed the cows being fed and they're having the methane levels measured at the same time. So just to finish up, it was found that the seaweed used in the feed interrupted the chemical processes of methanogen bacteria in the cow stomachs, and this led to less methane being produced during the rumination. But just to mention that the scientists did find that the cows burped more carbon dioxide, but this is a greenhouse gas that doesn't warm up the planet as much as methane. And similar findings have also been reproduced multiple times in cows and also chickens. And you can see all the data there if you prefer bar graphs to burping cows. So the critical finding really is that adding more seaweed to the diet reduced the methane levels, and there was no habituation period when the effect diminished. In fact, the cows aged and the feed moved, as the cow aged and the feed moved to more a typical mid to low forage diet, the reduction in methane increased. Thank you for that, and I'll hand it over back to Peter.
Peter, for some reason we can't hear you now.
Hold on, can you hear me now?
We can.
Yeah, okay, sorry. I've probably got about 10 minutes. Do I have enough time for that, or are we running a bit tight?
Go ahead, Peter.
Okay, so I'll do a real whistle-stop tour Bringing it back to health. Okay, so we've been consuming seaweed for centuries, in the UK and in Europe, but for Eastern Asian communities, they've been consuming it for like thousands of years. So on the right hand side, we've got lava bread. This was first reported in 1607 in this book Britannia, and we know that also Irish sea moss was consumed during the potato famine of the 1840s. So it's always been like something that we've gone to when we've needed to. In terms of current intakes in Eastern Asian communities, they've maintained their intake but at relatively low levels, whereas we said before, as Rikke mentioned, it's practically absent in the UK and EU diets. Now, critically, when we talk about traditional Eastern Asian diets, it's really important to know that it is small amounts. People aren't going out and chewing, crates full or kilograms full of seaweed. It's been added as a something to give a taste or a texture or reduce the salt content across a whole range of different foods within the diets, from soups to sort of pickled ingredients or added to a salad. The critical thing that I really wanted to get across here is that if you look at this diet, this doesn't look anything like a Western diet. This is a diet which is low in fat, low in energy anyway. There's very few processed foods. There's a lot of dietary sort of plant-based foods and also other fish sources. So when we look at the benefits of a diet, a traditional prudent Eastern Asian diet which contains seaweed, we need to take into account that some of those data might be influenced by this whole diet, not just the seaweed component. Rikke's already covered a lot about the seaweed composition. It's a really low-fat source, high in B vitamins. She did mention I would say something about iodine content, so that's what I'm going to do. Especially brown seaweed's a really rich source of iodine, so that can both be a benefit, a reward, but could also be a risk as well. So in terms of iodine, we know that we need iodine. It's for growth regulation through thyroid hormones, and as women go through those childbearing ages, especially if they're pregnant, then their demands for iodine increase quite substantially. Now, globally, there's a bit of a deficiency issue regarding iodine intake. And although I think it was when people consumed a lot more cow's milk, the iodine intake deficiencies in the UK were a lot lower. Because there's a move towards a more plant-based diets, some of those iodine deficiencies are increasing. And when we look on the right hand side here, the sort of main sources in the UK diet of where iodine comes from, it's clear that vegans and vegetarians, well, specifically vegans, are really in danger of being iodine deficient. So one of the questions that we could look at in future studies is whether seaweed products could reduce iodine deficiency, specifically in those populations. One thing that I would draw your attention to is that there are max tolerable doses in the EU, and EFSA have quite stringent guidelines about 600 micrograms for adults and 200 micrograms of children. Again, it's hard to get this in dried processed products because you need to eat an awful lot of them. Okay, so in terms of how healthy diets are with seaweed or containing with them, I'm going to give a very whistle-stop tour about population-based studies, some in vitro data, and also a limited number of randomized control trials that have been conducted. When we look at these associative data, which are across thousands and thousands of people, almost exclusively from Eastern Asian populations, you'll see that there is a general protective effect of consuming seaweed specifically, and a reduction in cardiovascular disease in terms of stroke, cerebral infarction, ischemic heart disease, etc. We know as a long-term indicator of aging, the leukocyte telomere length is actually greater in those that consume more seaweed. And on a slightly different lilt, which I know is of interest to NIHA, sort of mood and cognitive function and mental well-being, we know that actually those that consume seaweed have less number of depressive symptoms, and also the amount of times that they're diagnosed with clinical depression is a lot less. And we know also that there's some emerging data about how this may well change the gut microbiota and increase the alpha diversity in the gut microbiota. Now, going back to my caveated part with the caution I said before about looking at about a prudent Asian diet, accepting that, those diets that are seaweed containing prudent Asian diets also seem to reduce the levels of non-alcoholic fatty liver disease, sarcopenia, metabolic syndrome, obesity, and also increased lung function. So at an associative level, there seems to be something there. So what might be the constituent parts? Again, really quickly over this. Macroalgae is really good at having very complex molecules in them, as Gill mentioned. The polysaccharide component is particularly important. We know that this is poorly absorbed in the small intestine and goes to the large intestine where it's fermented. We know that this has an impact upon immune function and affects the mucosal lining of the gut. We also know that it's got anti-inflammatory capacities, and really that sort of component is really important. And there may well be just as much importance for some of the more structured, complex polyphenols as well, where my interest originally originated from for this, sort of fluorotannins as well. They have almost the same sort of physiological capacity. They're not absorbed well, and they go to the gut to be fermented. So I'm not going to go into any great detail here. There's been lots of in vitro and animal models that have shown algae or extracts of algae or all sorts of different types of seaweed, and even all the way down to the polysaccharides, seem to have gut effects, increasing things like short chain fatty acids or changing the preferential sort of ratio of good to bad bacteria in the gut, which are related to immune function, and also some other indicators of the structural integrity of the gut are improved in animal models where seaweed is fed. In terms of cardiometabolic health, we've seen that there's this inhibition of fat and glucose digestion and absorption, which is sort of created through this reduction of the activity of amylase and glucosidases. And in longer term studies, they've seen not only that weight gain is reduced, but also there's a sort of a readdressing of imbalances in terms of lipid and lipoprotein profiles in animals that are fed a high-fat diet. In terms of those polysaccharides, again, in diabetic animal studies, they've shown really good results in terms of fasting blood glucose and oral glucose tolerance tests, and improvements in the insulin sensitivity and also the utilization of insulin. In terms of brain health, we know that there's some nice mice models in those animals with dementia models or Alzheimer's disease, where they've been shown to reduce the impact of amyloid beta and tau. And also, we know that memory is improved in some of these tests, and there's specific changes that have been shown in the hippocampal region that we know is related to memory. So in terms of human studies, what's out there? Well, not too much. There is quite a lot about glycemia, and what's been shown that in both postprandial and in fasted glucose settings, that seaweed, either addition to a single meal or throughout the diet for between 4 and 12 weeks, can reduce the levels of glucose in the blood. The effect seems to be slightly more effective in type 2 diabetes than in pre-diabetes. There's a whole host of other studies, and I've tried to identify those in increasing duration here, from nasal sprays in children to reduce the viral load, to reducing lipid levels, to reducing inflammation, and also increasing immune functions, also adipose tissue markers, and yeah, you can see here that there's a few studies which have showed that there are no effects of certain seaweed under certain circumstances. But for instance, the study by Murray, this wasn't a very well controlled study, so I think that might well, discrepancies between the populations might well be an issue here. So really, just to kind of identify what the gaps are, where we're trying to fill those gaps with research in the future. We're trying to understand whether polysaccharides or polyphenols, or a combination of both, is what driving the effect. We're looking to try and do some studies where we are more robustly looking at the vasculature and cardiometabolic evidence, specifically as well looking at biomarkers in terms of metabolite levels. What we don't know is, although the NLP is a real rich resource for digestive diseases, there are no studies at the moment that have looked at populations with digestive diseases, and that seems a really obvious area where we could look at. I know there's interest in weight loss, but also weight maintenance or loss, the maintenance of weight loss in obesity. Again, this is something that the epi data seems to suggest that could be a thing. And also cognitive function, although there have been some studies in cognitive function, they've tended to be in younger, healthier people without any level of cognitive dysfunction. So there's a real opportunity there. Talking back and just really reiterating what both Anne-Marie and Rikke has said, the Algal Innovation Platform is ongoing. We recently did a community engagement event at the Forum, which was part of Norwich Science Festival, where we had an activity stand and we gave a talk. These are just some of the literature that we had out there. And here's some sort of images of both Gill and Rikke actually getting their hands dirty and me standing back and looking on and not really doing a great deal. So there we go. We had a lot of fun, and we had a lot of engagement from the community. They seemed very interested. So sorry for just rattling through that last bit, but thank you for your attention. Do you have any questions?
Oh, thank you so much, all three of you, just for really, really comprehensive sets of presentations. I know a couple of people have to drop out at 1 o'clock, but most of the attendees are still here. Would anybody like to ask a question? Either unmute yourself and turn on your camera, or else pop your question in the chat box. Maybe I can start off. Rikke, you showed some food products, which I think are fair to say are quite high-end food products. And that's often where a lot of sort of nutrition innovation ends up, that it often leads to really kind of well-founded, sophisticated, but expensive products which tap into a certain area of the market. I mean, what do any of you speakers think about the potential for seaweeds to kind of make it into commonly consumed food products and fill some of the sort of the macro and micronutrient gaps that we have? Things like, you know, compensating for low fiber intake, the fact that our diet is quite low in iodine. Is there any kind of innovation in that direction rather than the kind of high-end food products that we know of? Gill?
Nope.
I think one of the great uses of seaweeds is you can buy dried sort of seaweed sprinkles and put them into your food. They give a really good flavour, and they actually reduce the amount of salt that you require for that food. And I think that's a really good sort of like an introductory product. And there's also quite a lot of food manufacturers who are used to wanting to use seaweed in that regard, just to get down below the salt regulation levels.
Yeah, great.
Yeah, I think I second Jill on that one. Is seaweed seasoning and seaweed spaghetti, and anything that can lower the barrier to consume more seaweed, really. So, as I mentioned, it's really common that products mimic animal-based products or other types of products, and that is seen as really lowering the barrier to consume more seaweed.
Brilliant.
Perhaps I can just add, what we don't really want to encourage people to do is to go out and forage seaweed for themselves necessarily. You have to have some caution. The products that you would get on the shelf in the supermarket have gone through various tests and things, and I think that's probably quite important. I wouldn't hesitate to use a really small amount, but we really need to think about those natural populations of seaweeds and to maintain them rather than damaging them. And we do have a couple of UK companies, unfortunately, who are taking a lot of seaweed from natural shores to make their products, which I do have a problem with.
Thanks, Jill. Maria Tracker said, great talk. She had to pop off, but she'd like to catch up with you guys later. Jenny says, are all seaweed suitable for vegetarians? And how much do you need to eat before you start getting benefits?
Yeah. Who's going to go for that?
I'll go for the how much you need to eat.
Yeah.
I think we need to sort of be quite cautious about how much we're eating. Really, the iodine content in some of them is astronomical. You know, you wouldn't want to consume them on a daily basis. I think buying them from accredited sources, which enable us to monitor the levels more safely, is a really key thing. But I think from the data, from the epi data, but also from you know, some of the experimental data, the amounts that people are adding to get benefits is small, like sort of 4 or 6 grams of dried product. It's minuscule amounts, and that's you know, really kind of, I think that actually has benefits. We can add it to other things, and yes, it does have a very distinctive taste, but you can put it onto things like salads and soups and stews and all sorts of things, and you can pack quite a punch. So I don't think we need to eat too much to get benefits, but obviously those long-term studies that have proven those benefits are not there. We've got some, you know, 8-week, 12-week, 16-week studies. You know, they need to be longer studies, and we need to also test safety at the same time and look at biomarkers just to make sure that whatever effects we are seeing are being as a component part of increasing in specific compounds as well. I think it's important.
I think it's important to add that some of the products that are being made do have a warning to say that if you're allergic to shellfish, you should avoid them. And that's because, as I explained, seaweed grow amongst a very complex population. And when they're harvested, they're not necessarily cleaned of every last organism, you know, especially really small things. Marine snails are very prevalent in the environment. So when you're producing tons of product, then I think they have to be wise and put that sort of caution on their products.
And I think, just to shoot in there, I think that's the only argument that's been made with regarding seaweed being vegetarian and vegan. Other than that, it's definitely suitable for vegan and vegetarians.
Yeah, thanks.
Can I just add as well that actually, you know, I've kind of raised the awareness of iodine content and being potentially problematic, but we do know that there are processing techniques that can reduce that level quite substantially by, you know, by boiling it, can reduce that level by about 80-odd%. So I think it's about being able to do it in a controlled manner where we can retain the good stuff and get rid of some of the stuff that could be a problem if we ate too much of it.
I mean, I think I was completely impressed by the size effects that you presented, Peter. I mean, they're massive for single foods. You know, there were like 30-40% reduction in the incidence of some of those, which are tremendous.
Yeah, I mean, these are lifelong consumption of these foods. And the top ones I showed in the epi data, they were all attributable just to seaweed. That wasn't as part of a prudent diet. So I think, you know, you don't need to consume too much. And I think that they could be really useful for us.
So I think we have time for 2 more questions in the chat box, and then we'll finish up. One is a really important question about seaweed being harvested sustainably. And is there any concern that if we suddenly think seaweed is a great food, that we have detrimental effects on the marine environment?
Yeah. So perhaps I'll take that one. I mean, as I mentioned, when you look at the Earth system as a whole, the marine environment is incredibly important, and we really have to avoid the sort of damage that agriculture has made to land-based systems. So it's a really good question, and you have to take into account the fossil fuels that are used for boats and for processing machinery and all that sort of thing, and do really complex life cycle analysis in order to show that this is sustainable. I don't really see any legislation in place at the moment that would back that up. But I think I do worry a lot about the carbon credit side of things, because actually proving how much carbon is sequestered and where in an organism that's floating in the sea is pretty hard to do. And there aren't very clear-cut studies on that as yet. So there's a lot of science going alongside this, which hopefully will help to make a sort of more complete picture. Really good question, though. We really do need to do it sustainably.
And finally, I think it comes back to the point we made at the beginning, you know, what strategies can we use to make seaweed more culturally acceptable, and kind of fit into the food insecurity, deprivation and decreased culinary skills so that products are more acceptable to a wider range of people. What should be our approaches?
Perhaps Rikke could take that one.
Yeah, I think it comes back to the point that we made earlier. I think as the seaweed industry increases, there will be more products becoming available on the markets, also in the UK. And I think it will move away from mimicking animal-based products as time goes on, as we get more and more used to eating seaweed and introducing it to our diets. So obviously that's a huge trend that we see at the moment, but it's the consumer acceptability, and it's also the same issues that we see, you know, within the phobia, eating more insects, for example, introducing more new things to our diet. We are really used to eating meat here in the UK, so it will take time to try new things. So I think with time, it will become more acceptable and we will consume more of it, and we will see new products on the market as well.
Thank you all very much. I think we'll leave it at that for today. Really exciting area, and yeah, let's hope this is the beginning of kind of great things, and yeah, let's hope NIHA can be part of that, really. So I'll just bring up our last two slides just to show you our next month's presentation. So our next speaker for NIHA on the 5th of May is Jane South, speaking on community-centred approaches. She's from Leeds Beckett University. So please come along if you can. This is a really interesting topic and something very close to our hearts in NIHA. And finally, just to say, yeah, please do get in touch if you have any comments, suggestions or questions. And just to say, we've launched a new NIHA website today. So please go on there and have a look, and it kind of shows our recent successes, the activities, the projects that are ongoing, and the main features of our three main themes in our co-production partnership. So I think we leave it there for today. Thank you for joining, and have a good weekend, everyone.
Thank you so much.
Many thanks.
Take care, everyone. Bye-bye.